Dear students, welcome back to our channel Easy Explanation. In this tutorial we will be learning about how to solve the problem of Tower of Hanoi using recursion in C programming language. So for those who do not have idea about what the Tower of Hanoi problem is, I have written down the description here. The Tower of Hanoi is a mathematical puzzle. The puzzle consists of 3 peaks / rods. One of the rod has a number of discs of varying diameter placed one on top of another in increasing order such that disc with a smaller diameter is at the top. So the objective of this Tower of Hanoi problem is, or the solution of the Tower of Hanoi problem is, to move entire disc from source rod to one of the rod via the auxiliary rod. So we'll have the 3 rods. One rod will act as a source rod, another will act as a auxiliary rod, and another it will act as a destination rod. So our objective will be to move all the disc from the source rod to the destination rod through the auxiliary rod. Now while moving the disc from the source rod to the destination rod through the auxiliary rod, there are 3 conditions that we need to keep in mind. Only one disc can be moved at a time, only the topmost disc can be moved, and the disc with the larger diameter cannot be placed on the top of disc with the smaller diameter. So these 3 conditions need to be kept in mind while moving the disc from the source rod to the destination rod through the auxiliary rod. So I'll draw a diagram representing that. So let us say this is the source rod, this is auxiliary rod, and the another one is destination rod. Okay, I will name it as A, B, C. So this will be the source rod, SRC. This will be auxiliary, AUX, and this one is the rod C will be the destination rod, DEST. Okay, and this source rod will have number of discs of varying diameter, means the disc with the smallest diameter will be at the top, the disc with the largest diameter will be at the bottom, and all other discs will be the intermediary discs. So the disc will be arranged in the increasing order, okay, in the increasing order of its diameter. Now how to move the disc from source rod to destination rod through the auxiliary rod. So let us consider first when the value of disc is 1. So when the number of disc, I'll say number of disc as a variable n, when n equals to 1, then we do not need auxiliary rod, we can directly move the disc from source to destination. So when n equals to 1, move disc from source to destination. Okay, so we'll start the code side by side. So I'll write has include stdio.h int main int num. So num will be the number of discs, and I will represent the 3 rods by a character variable SRC. I will name this SRC as A. Then we'll have auxiliary, which will be rod B. Then we have destination rod, which will be the rod C. Okay, once we have declared all these variables, I will ask the user to enter how many discs you want to have in the source rod. So enter the number of discs, so scanf %t ampersand num. I will call a function called as a move. This move function will be a recursive function that will help you to move the disk from the source to destination through the auxiliary rod. So the move function will have the argument num, which will be the number of disk, and then we'll pass the argument means source, auxiliary and destination rod in the similar fashion, like source, auxiliary and destination only. So the order of argument will be like first source rod, then auxiliary rod, and then destination rod. Okay, and finally return 0. Then I will define the function move, void move, then we'll have int n, char s, char a and char d. Okay, now we have defined for if num equals to 1, if the value of n equals to 1, we can directly write printf /n move the disk number means %d disk we can write move disk %d from rod %c to %c. So if the number of disk is 1, then we can directly move from source to destination. So we can write for %d will have n, if n equals to 1 it will print 1, and for the first %c will have source, and the second %c will have destination d. Okay, so the problem will arise, or the recursive function or the recursive concept arises when the value of disk is more than 1. So when the number of disks become 2 or 3 or 4, then what will happen? For that we have to write the code. Now before writing the code, let's understand the logic. Now let us say when the value of n is greater than 1, so let us say the value of n equals to 4. Okay, when the value of n equals to 4, then how will move the disk? Okay, so I'll choose this color red. So disk 1, on top of that another disk, two, then we'll have disk 3, then at the top we'll have disk 4. So let us say this is the disk 4. Now our objective is to place the largest disk which is at the bottom, or the fourth disk which is at the bottom, to the destination rod. We have to place the largest disk which is at the bottom to the destination disk, but according to the condition we can move only one disk at the time, right? So what we have to do is we have to find a way to first move all the top 3 disks first. So if I can move the first 3 disks first, then only we can move the last disk, right? So if the number of disk is 4, then what we have to do is, if n equals to 4, then we have to first move all n minus 1 disk to auxiliary rod. So we have to first move all the n minus 1 disks. So n minus 1 means we have to first move the 3 disks, the top 3 disks, to the auxiliary rod. So once all the top 3 disks have been moved to the auxiliary rod, following all the conditions that is specified for the Tower of Hanoi, then we will be remaining with the last rod. Okay, so we'll be remaining with the last rod. So what we can do is, now once we have the last sorry, we'll be remaining with the last disc. So then we can do what? We can move the last disc from the source to destination. So when all the n minus 1 disc has been moved to the auxiliary rod, then move the nth disc to the destination rod. Okay, now once the last disc moved to the destination rod, then we'll have something like this. For n equals to 4, what we have done is we have moved the first n minus 1 disc to the auxiliary rod. So we'll have the 3 disc over here, 2 and 3, and the largest disc will be at the destination. Okay, the largest disc or the fourth disc will be at the destination, right? Now so now we have to find out a way to move these 3 discs to the destination disc, right? We have to find a way to move these 3 discs to the destination disc. So then the last step that we have to do is again move n minus 1 discs at the auxiliary rod to the destination rod via what? Source rod. Okay, so we have to move what? This n minus 1 disc to the destination rod via the source rod. So you can use now this rod as a auxiliary rod to move this n minus 1 disc. So let us write the code for this, what we have written here. So if the value of n is greater than 1, then what we have to do is we have to move n minus 1 disc. First we have to do what? We have to move the first n minus 1 disc from source rod to the auxiliary rod. So for this n minus 1 disc, what we have? The source is the original source, destination is the auxiliary rod, and the auxiliary rod for this n minus 1 disc will be the destination rod, right? The auxiliary rod will be the destination rod for n minus 1 disc. So we have to specify that also here. So for n minus 1 disc, the source rod will be the original source rod, and the auxiliary rod will be the destination rod, and then the destination rod will be your auxiliary rod. So you can write it like that. So once the n minus 1 disc has been moved to the auxiliary rod, something like this auxiliary rod, what we can do is we can move the nth disc, to the destination rod directly. So we can write the printf statement. So printf, we can write the same thing again, Control C, Control V. Okay, now once the second step is done, then what you have to do is the final step. Now once the auxiliary rod is once the n minus 1 discs are at the auxiliary rod, then we have, by the second step, we have moved the largest disc to the destination rod. So the largest disc is at its position now. Now we have to place this n minus 1 disc to the destination rod. So in order to move this n minus 1 disc to the destination rod, what you have to do is, here for this n-1 disk, the source rod will be auxiliary rod, this source rod will be auxiliary rod, destination rod will be the destination rod only, and it can use this original source rod as the auxiliary rod. So for n-1 disk, this rod, the source rod will be act as the auxiliary rod. So auxiliary rod will be the source rod. Okay, so now let us move the n-1 disk to the destination rod through the auxiliary rod. So move the n-1 disk from the auxiliary rod, which is act as the source rod now, from the auxiliary rod, which is the source rod for that n-1 disk, to the destination rod D via the source rod. Okay, so this will move first n-1 disk from source rod to auxiliary rod via destination rod, and this statement will print something like move the nth disk from source rod to destination rod, and then finally the disk that is at the auxiliary rod, so the n-1 disk at auxiliary rod should be moved to destination rod via the source rod. Okay, so this is the concept of Tower of Hanoi. Let us compile this code and see whether it is producing the desired result or not. So if there is any error or any logical error or syntax error, we'll try to solve that. So okay, so on declaration function here, so the function need to be first, the prototype need to be declared for that function move. So okay, I hope this will compile now successfully. So it is DEST, I have written DES only, so there is spelling mismatch. Okay, if the number of disk is 1, so move disk 1 from A to C, this is done. Now if the number of disk is 3, then it is saying us first move disk 1 from A to C. So you can draw 3 pegs or 3 rods and then 3 disks in rod A, then you can verify your result there. So first move disk 1 from A to C, then disk 2 from A to B, and then disk 1 from C to B, disk 3 from A to C, disk 1 from B to A, disk 2 from B to C, and disk 1 from A to C. Now you can see the first 3 statements move the n-1 disk from source rod to the auxiliary rod, source rod to auxiliary rod, and this statement will move the nth disk to the destination rod, and the last statement last statement will move the n minus 1 disk which is at the auxiliary rod to the destination rod. Okay, so in this way we had used the concept of recursion to solve the problem of Tower of Hanoi. So this is the code. Okay, I will zoom out. Okay, now it is visible in the single page, so please have a good look at it. So this is the code to solve the problem of Tower of Hanoi using the concept of recursion. I have mentioned the required comment line for you people to understand, and if you have any queries regarding this Tower of Hanoi problem or how I did the code, please mention in the comment section. Please like, share and subscribe our channel for more upcoming videos. Thank you very much.